Okay, to draw the roller lever. The roller lever, first, of course, we need to notice that it is metric, so we need to keep that in mind. And as far as a sketch I'm going to draw, the general sketch I'm going to draw from the back surface. It's going to be the edge here, a line and arc, a line, a line, a line, line, a line, an arc that's tangent, a line to this edge here, which actually be over here in the back. And then, sorry, and then up this way, and a 45-degree angle to close it up. Okay. So sorry, my sketch doesn't look very pretty, but nonetheless, it is going to be one sketch, and I'm going to be mostly getting everything I need from that one sketch. Okay. So let's start drawing it up. It is metric, new, metric part file, standard millimeter IPT creates. Okay. So I'm going to go create a new sketch. I'm going to start on the XY plane. And let me think a little bit of how I'm going to do this. I'm going to do that one sketch. I guess I can extrude the whole thing and then cut it back. Yeah, I think I'll do that. I'll extrude the whole 43 millimeters and then cut it back and then do this part right here. Got it. Okay. So I'm going to draw myself a line. Once again, just not exact, but it does need to be as close as possible. So I'm going to start with a line across this way. And then on the back edge over here, that's about, I don't know, maybe about 20 millimeters or so. Up this way, a 45-degree angle from here across this way. And, I got to be careful because you see this little line that's drawing to the bottom. If I leave it that way, it might constrain itself to the midpoint there. So I really don't want that. So I want to, when I sketch it, since I don't want it to be aligned with these, I want to just make sure that I don't see that. So I'm going to stop at that point in particular. There's an arc that comes this way down, and it's not tangent. So I'm going to have to, unfortunately, stop the line command and draw that arc that I need. I don't like to do that. I usually like to draw my whole sketch all in one shot. That way it constrains itself a little bit better. And right in here like that. Okay. And then I have another line that comes from this endpoint here up to a certain point. And then it's going to come across flat, horizontally. There we go. And then 45-degree angle down this way, 45-degree angle. And I do want these to be aligned with themselves across this way, across this way. And then there's going to be a tangent arc that's going to come across. From here, I'm going to press and hold and drag an arc down this way. And then another tangent arc, press and hold, and another tangent arc down to here. Got it. It applied that tangent constraint, and I'm kind of glad it did because I need to delete that one. That is not going to be tangent down in here. So down in here, you can kind of see that that circle or that arc is not tangent, but it constrained itself to be tangent, and that's okay. But it gives you an opportunity to show you how to get rid of constraints because it will happen every once in a while. Okay, hit escape and F8, F9. All my constraints that applied on its own. More than likely, I'll be using most of these perpendicular, parallel. So yeah, I think those will mostly work. There's a few I'm gonna have to apply. So let's go with coincident constraint as always. I'm gonna apply coincident, no reason in particular, but I'm just gonna go coincident from this point over to the origin. Okay, if I did middle, it doesn't really matter. In this case, I'm not gonna, there's not a huge benefit of where it is, and for this one part in particular. I do need to get rid of this tangent constraint. I'm gonna hit escape. This tangent constraint I don't need, so I'm gonna select it. Oops. Select the constraint, right click, and delete the constraint. So I need to specifically delete that constraint because I don't need it to be tangent. So that way it does this the way I want it to. Okay. All right. So look at this, 20 dimensions. OMG. I will tell you there's a lot of geometry I need to take care of first. So This one is going to be a little tricky because this edge here, which is actually this one, if you kind of notice, it goes up to this point. This point is the center of this arc, the 29 millimeter radius arc, and it's along this back edge. So that center of this arc actually needs to be along that back edge. Okay. So that's one of my constraints. And that one, I don't think there's a geometric constraint I can apply from here. So usually what I do, it's since this is the center point of this arc, and how do I know that is if I drag it around, notice that it moves the arc a little bit. So, and this one is obviously this one over here, and this one's for this one. So the center point, I need it to be along this line. So I'm going to press and hold it, drag it, and drop it onto that line so that it stays on that line. And I need that to happen. So you notice now it's on that line. And then the other thing I need to do is I need it to be horizontally aligned over here. Notice I'm down to 19 dimensions. So I'm going to go horizontally align this point with this point right in there, down to 18 dimensions. Geometrically, I think that's pretty much it. So I think it's just going to be 18 dimensions. Oh, there we go. There's another constraint I need to add. That does need to be tangent from here. It needs to be smooth. So that is a tangent constraint I'm going to apply between this arc and this line. Geometrically, let me see what else I'm needing. I think I'm going to horizontally constrain. Oops. Undo that one stop. Horizontally constrain. I'm sorry, vertically constrain. This point and this point, I do need that to be vertically constrained. 16 dimensions. And I think the rest is going to be my dimensions that I need. Okay. So I'm going to start applying the dimensions that I need at this point. Very good. Okay, so we got a dimension of the top to the bottom of 57 millimeters. And this is way off. I hope it doesn't mess up my sketch. Okay, it didn't. Look at that. Because I had all my geometry done well, it didn't mess up my sketch too much. So dimension from this line to this point is 5 millimeters. The angle from this line to this line is 45 degrees. 29 millimeters. This one here is 29. The radius of this guy is 29. The radius of this guy here is 5. The distance from this line to this line is 19. The overall distance from here to here is 81. Don't worry, this will be, you can review this video, this line here on your own a little bit later. I'm just going to fly through everything so I can have a nice, clean, quick video for you. I'm not going to dimension this one. I suspect that if I place it, no, okay. I don't think I needed that one, but I'm going to go ahead and place it at 7 millimeters. And then the overall of 32 from here to here, 32. There we go. So I'm down to 5 dimensions. Okay. So 29.
Good morning, Rebels. This is Student Council.
So the other dimensions I need is going to be the angle of the of this feature over here of 45 degrees. Okay, so that one is a driven constraint. So I'll accept it just to show you. This is driven. So basically it is 45 degrees. That's what it says on the drawing. So it's correct. The thing though is that it's driven more than likely because of my constraints. Because of my constraints, and this is parallel, perpendicular to this one. And this one's horizontally aligned with this one. So I'm not sure why it is exactly 45 degrees. I'm guessing because of these dimensions. But it's because of this geometry that it constrained itself with. Because of that, it's 45 degrees. So in this case, it happens to work for me. If this is not correct in yours in the future, you might have to delete some constraints, but that's not the case in this one. So I'm still at 5 dimensions. And if I leave that there, it's not a problem. So let's continue. I have 14 millimeters from this edge to this edge here. That is 14 millimeter distance. The radius of this one right in here is 19 millimeters. And a 10-degree angle from this line to this angle is 10 degrees. 2 dimensions needed. Okay. All right. So what 2 dimensions do I still need? I need the 24 millimeters from this edge to this one. That needs to be 24 millimeters. 1 dimension needed. Oh, 24 millimeters from here to here. That's going to be 24 millimeters, fully constrained. Very good. Okay. Once again, I'm just using the dimensions that are here. I should not have to make any of these up. Basically, it's all here. So these are the dimensions I need. Fully constrained, finished sketch. Okay. So in this case, what I'm going to do is I'm going to extrude that shape the entire depth of 43 millimeters. Okay. So I'm going to go with 43 millimeters for the entire depth from here to here. And then what I'm going to do is I'm going to, either one would work, but I guess I'm going to create a sketch so I can cut this part back in here and have the 24 millimeters that's left over. So I'm going to go ahead and create another sketch on this face. And I'm going to draw 2 lines. The line I need to draw is down from here to here. But remember, don't forget to, don't constrain yourself to midpoints or nothing. So just make sure that the line that we need is just somewhere along here down to this edge here. I forgot to project some geometry. So let me project cut edges. And the other line I need is the line that comes from here across to this point. And that one constrained itself already because it's going from a fixed point to a fixed point. This one is not fixed. I only need 1 dimension. I can tell you right now it's going to be from this edge to this edge, right in here, and that one is 52 millimeters. Okay. Now that I got that finished sketch, I'm going to go ahead and extrude this portion and this portion as a cut extrusion. I don't know the depth of this cut extrusion. I do know that the overall is 43, and what I need to have left over is 24. So I'm just going to do 43 minus 24 for that cut extrusion there. Okay. Now, the other part that I need to do is this part right in here. Okay. So somehow 12 millimeters away from the back edge, I need to sketch this arc and then cut that arc a total of 24 millimeters. So here I can introduce a concept of called a work plane. So I'm going to sketch a plane on the back over here. And that plane on the back, I'm going to create a work plane. And we have different ways of creating work planes. What I'm going to do is I'm going to create a work plane that's offset from a plane. So I'm going to click on this option right in here. And I'm going to pick the back geometric plane from here and offset at a particular distance. But in this case, it would be positive, but I need to go this way. So I notice it just makes it negative. So I'm just going to go negative 12 millimeters. Negative 12 millimeters, check. Now I have a work plane that represents this surface right in here. Eventually I'm going to extrude it 24 millimeters, but I am going to create a sketch on this work plane. I'm going to slice my graphics F7 up to this edge right in here. Okay. I'm going to project cut edges and I'm going to draw myself an arc, a 3-point arc. So I'm just going to pick an arc. I'm not going to get the midpoint. I just want to make sure that the arc is on the line somewhere. Here and here. Okay. Sorry about that. 3-point arc somewhere along here to end here. And then somewhere in here is going to be my 3-point arc. It's going to ask for 3 dimensions. So really the 1 dimension that I need to put numerically is a radius of 41, but I also need it to be along this back edge here. So that's actually going to be my geometric constraints. So this center point actually needs to be horizontally, vertically aligned. So I'm going to vertically constrain this point to this point. 2 dimensions needed will be my, well, I can tell you right now, it's going to be a dimension radius of 41 millimeters. And then the one dimension I need, oh, there it is now from the top edge to the bottom edge of the arc is 36 millimeters. So I need to go 36 millimeters from this edge here to this point right in here. 36 millimeters, fully constrained, finished sketch. And then I'm going to go extrude that profile there from this point as a cut extrusion, 23 millimeters, 24 millimeters, sorry, as a cut extrusion through there. Get that part that we were missing. Okay. The work plane is still visible. If it bugs you, you can right click over here on the project browser and just simply turn off the visibility of the work plane. Get rid of that. We're just missing a couple of drill holes. So let's go ahead and place a drill hole on this surface. From the bottom edge is 24 millimeters. And from this edge here is 14 millimeters. It's a simple hole, not counterbore. It's a simple hole with a diameter of 11.40. I'm sorry, not 11.40. 11.41. It's actually the two holes that are 11, the two holes, these right in here, sorry. 11.41, and then we'll do this other one right now. 11 point, why do I keep saying 11? Yes, it is 11.41 diameter. Okay. And then this other drill hole over here on this surface, from the back edge, 14 millimeters, and from the bottom edge, 14 millimeters. And that one is a diameter of 14.30. 14.30. That, ladies and gentlemen, is how you do the roller diagram.